Hello, students, and welcome back. We are starting a new topic today, and this is kind of a little bridge topic that we need to cover before we move on to what we're really wanting to talk to you about. We're going to be working with quadratics eventually, and with quadratics, you'll often run into square roots that sometimes have negative numbers, and you haven't encountered that too much yet. And in fact, we have a new number that we are going to introduce to you. So this new number is called I. It's an imaginary number, and we're going to define I as the square root of -1. And that's going to allow us to deal with square roots of negative numbers. And this will lead us to a new set of numbers called the complex numbers that will have some characteristics that are similar to what you've already been working with. So you're going to need to have this new definition for I. So it's a number, it's lowercase I, equaling the square root of -1. I squared is going to be defined as -1. And so if you run into a square root of a negative number, then maybe you need to show a step where you show that it's the square root of -1 times the square root of the number. But how we'll leave your answer is that it is I times the square root of that number. So I have a few examples for us to simplify. And we haven't done a lot of work yet with square roots, so we may need to just do a quick review of that. So my first one is the square root of -81. And hopefully you're thinking there's nothing that you could multiply together that would give you, when you take it times itself, that would give you a negative. And that is true. 9 times 9 is 81. -9 times -9 is 81. And for there to be a square root, it's supposed to be a number times itself. So this is where the imaginary number I comes in. So we will say that the square root of -81 is the square root of -1 times the square root of 81. The square root of -1 is I, and the square root of 81 is 9. 9 times 9 is 81. And then typically we write this a lot like you would if it was a variable. So 9i would be your final answer. And that is the imaginary number, 9i. Now, if you have a square root that is not a perfect square, I'm going to show you maybe, I hope, a little reminder of how you simplify that. So first of all, we're going to make it the square root of -1 times the square root of, now my 32, I'm going to take my 32 and break that down. So 32, I'm going to do a factor tree. We'll divide by 2 and 16. And then 16 is 2 and 8. And 8 is 2 and 4. And then 4 is 2 and 2. So I end up with 1, 2, 3, 4, 5 2's. So 1, 2, 3, 4, 5 2's. And then my y to the third, I have 3 y's. I can write those all out. This is how we simplified with square roots in Algebra 1. So a review on that. Well, our square root of -1 is our new definition. So this is I. And then we're going to simplify by circling pairs. So I have a pair of 2's, I have another pair of 2's, and I have a pair of y's. What we circle will be taken outside of the radical. So I have a 2, I have another 2, and I have a y. Those groups were circled and are out of the radical. Anything not circled stays in the radical. Those are not perfect square powers. And so I have a 2 and a y left in. And then I can write my answer And usually we put the I right in front of the square root. So on the outside of the square root, I have 4yi. And then on the inside of the square root, I have the 2y. So I have the imaginary number I involved in that simplified radical. And so we kind of treat it like a variable, even though it's a number. And so when you're multiplying with i's, they work just like a variable would. So 3i times 2i in example number 3, 3i times 2i is 6i squared, just as you might imagine. But the difference is that at the beginning, we were told that I squared is equal to -1. So 6i squared is the same as 6 times -1. And so that's going to multiply to -6. So you'll see that when we multiply two imaginary numbers, we get a real number, a number that we're familiar with that doesn't have I in it. And then finally, we're going to, in our last example here, multiply the square root of -12 times the square root of -2. Now, because those have square roots of negatives, they are not real numbers. So your first step cannot just be to multiply them. You have to recognize that we do have the square root of -1 that has to come out. So we'll have the square root of -1 times the square root of 12 times the square root of -1 times the square root of 2. Anytime you have the square root of a negative, you need to take out the square root of -1. The square root of -1 will be I, and so we'll have I times the square root of 12 times I times the square root of 2. And now we'll start multiplying things together. For example, the I times the I becomes I squared. And then we can multiply together the 12 and the 2. So 12 times 2 inside the square root would become 24. Now, I squared, just like our last problem, I squared becomes -1. And then our square root, we can break down. So I'm going to take that 24 and factor it. I'll do that up here. So 24 would be 2 and 12. 12 would be 2 and 6. 6 would be 2 and 3. So this is going to factor to 2 times 2 times 2 times 3. We can circle a pair of 2's, and that's because that's a perfect power that can come out. That will multiply by my -1. So I'll be taking 2. I'll have -1 that I'll multiply by the 2. I'm going to go ahead and show that. You might not need to. So -1 times the 2 that came out, and then inside the square root is still the 2 times 3, which gives us 6. So our final answer is going to be -1 times 2, that's -2 times the square root of 6. So once again, we took two imaginary numbers and we multiplied them together and ended up with something that did not have an I in it. So that's an introduction to imaginary numbers. Now we're going to look at how those fit together as what we call complex numbers. So a complex number is written in the form of A plus BI. A is what we call the real part, and BI is what we call the imaginary part. Sometimes they'll say the imaginary unit. And so you can treat the complex numbers much like you would something with a variable when there's an I, but you do need to remember the I is not a variable. So I'm going to scroll up and we'll take a look at our remaining examples. So our first two examples are addition first and then subtraction. And for addition, notice that I have the complex numbers grouped together, 3 plus 5i plus, and then 2 minus 4i. So I could remove the parentheses just to help me see the like terms a little bit better. So all I'm doing is removing the parentheses, and then I'm going to underline like terms. The real parts should go first, so those are the parts that don't have the I. 3 plus 2, regular adding, it's going to be 5. And then the imaginary parts, so the plus 5i and the minus 4i, will add the numbers in front. So 5 and negative 4 add up to 1, and we'll write that as 1i. You might see it just as 5 plus I. And then for subtraction, it works very similarly, but when you remove the parentheses, you've got to remember to think of it as taking negative 1 times each one of these so that you get the signs changed properly. So we'll have 4 minus 6i, and then we're going to do negative 1 times 3, that's negative 3. And we're going to do negative 1 times negative 7, and that's negative 7i, and that's positive 7i. Then, as we did with the previous one, we'll combine like terms. So we have the 4 and the negative 3. That's going to combine to 1. And then we will have negative 6i combined with positive 7i. That's going to be plus 1i. Again, you may see that answer as just 1 plus I. So you have the real part and the imaginary part. So that would be addition and subtraction with complex numbers. And then we have multiplication. So on number 7, you've got 8 plus 5i times 2 minus 3i. So we're going to distribute. I'm going to write that a little bigger for me to do my distributive. 8 plus 5i times 2 minus 3i. So I'll first of all do 8 times 2, and that is 16. And then I'll do 8 times negative 3i. Remember that you're going to get 4 blanks here filled in. So negative 24i. Then we're going to fill in this blank. We'll take 5i times 2, that's 10i. And then the last blank, we'll take 5i times negative 3i. So that would be negative 15. And then we have I times I, so that's I squared. So we have a couple of things to notice. First of all, our middle two terms are like terms. So that would be 16, and we can combine those, making negative 14i. And then the other thing I want you to notice is that this is I squared. I squared is negative 1. So this is taking negative 15 times negative 1. And negative 15 times negative 1 is positive 15. So, I'm going to put that positive 15 right here. And so 16 plus 15, those are going to be like terms that we can combine. And we always want to put the real part first. So 16 plus 15 makes 31, and then we'll bring down minus 14i. And so there's your multiplication, 31 minus 14i. And then finally, number 8, we have multiplication. Now, I do want you to notice that these two are the same numbers, but the middle sign is different. These are a special kind of multiplication. These are called conjugates of each other. And when we multiply conjugates, you'll find something unusual happens with those. So remember that you should get 4 terms when you do this multiplication. So we'll start with 6 times 6, that's 36. And then we'll take 6 times negative 3i, and so that's negative 18i. Then we'll move to the second term, 3i times 6, that's positive 18i. And finally, positive 3i times negative 3i, that will be negative 9i squared. Well, our negative 18i and our positive 18i actually cancel each other out. And that's what happens when you multiply conjugates. The I term actually goes away. So then we have 36 minus 9, and then I squared is, remember, negative 1. So you have 36, and then, now remember, order of operations, we should do negative 9 times negative 1. And so that's going to become positive 9. And 36 plus 9 is going to turn out as 45. So when we multiplied the conjugates, we ended up with a real number, a single number that did not have an I term anymore. So there's your introduction to complex numbers. We'll be using those as we work with the quadratics.